In section 5.3, we are going to be dealing with this new concept of solving trigonometric equations. And so in this video, we're just going to do a lot of examples of what that means. So for this first example, we are asked to find all solutions to the equation sine of x equals 0 on the given interval 0 to 2 pi. So I've drawn a coordinate plane, and let's see, if we're thinking about, this is 1, 0, this is 0, 1, this is negative 1, 0, and this is 0, negative 1. So we're trying to solve sine of x equals 0. So we're trying to identify all of the x values between 0 and 2 pi where the sine of x is 0. So that's going to be here. We have the sine of x is 0, and also here. And so these angles, this is going to be 0 or 2 pi. And this is going to be pi. So the solution to this particular question is going to be x equals 0, pi, and 2 pi, because these are all the possible solutions in our specific interval. Now, what if we had asked the question differently? What if we were asked to find all the solutions to the equation sine of x equals 0 for all x? So when it says for all x, we want a general solution, not just something within a specific interval. So let's see. We're starting off at 0, and then the next time sine of x is 0 is at pi, and then the next time it's at 2 pi. So our solutions are going to be x equals, let me use white again, x equals 0, pi, 2 pi. If we keep going from there, we'll get 3 pi. So if we write this up generally, the solution is going to be x equals k pi, where k is an integer. And recall, this means this is a set of integers, that's z. Okay, so we're trying to find all the solutions to the equation sine of x equals 0, so we're just identifying the angles where that happens, and that's the solution to our equation. So let's do another example. Here, we're trying to find all solutions to square root of 3 times tangent of x equals 1. And again, we're on this interval between 0 and 2 pi. So first, we need to figure out, let's see if we can simplify this equation. So we're starting off with the square root of 3 times the tangent of x equals 1. And if we divide both sides by root 3, we're going to get tangent of x equals 1 over root 3. So we're looking for all the angles x between 0 and 2 pi where the tangent of x is 1 over root 3. So let's see. I think we want to go to pi over 6. And so let's confirm that this assumption is correct. So pi over 6, our cosine is square root of 3 over 2, and our sine is 1/2. So if we do sine over cosine, we get 1/2 times 2 over root 3, so 1 over root 3. So that works. And then another angle that's going to work is, let's see, that's 7 pi over 6. And so here we have negative root 3 over 2, negative 1/2. Okay, so we're going to get that in this interval, it works at pi over 6 and at 7 pi over 6. So we get x equals pi over 6 and 7 pi over 6. Now, how can we write this in general? If we were to keep going outside of the interval, so let's say they asked for the general solution. So find all solutions to square root of 3 tan of x equals 1 for all x. What do we get? So we start off at pi over 6. The next time the tangent is 1 over root 3 is at 7 pi over 6. And then the next time that happens again is going to be at 13 pi over 6. And then again at 19 pi over 6. So what we're doing is we're just adding pi each time. So we can write this as x equals pi over 6 plus k pi, where k is an integer. And that will be the most general solution. So next example, we want to find the exact solutions to cosine of x equals 1 for all x. So, we're looking for the angles where the cosine is 1. So that's going to be here at 0, or 2 pi, and then that's it. There's no other places where the cosine of x equals 1. So the solution to this is going to be, we're going to be x equals 0. If we go back around, we'll be at 2 pi. If we go back around again, we'll be at 4 pi. So we get that the general solution to this is x equals, let's see, 2k pi, where k is an integer. Time for another example. And so this will be the most complicated of the ones that are on the video quiz. So here we want to find the exact solutions to cosine of x equals cotangent of x. So we have some solving to do. So we start off with cosine of x equals cotangent of x. And then let's rewrite cotangent of x as cosine of x over sine of x. So from here, what I want to do is multiply both sides by sine of x. And so what's going to happen on the left-hand side is I'll just have sine of x, cosine of x. And on the right-hand side, these will cancel, and I'll just get cosine of x. So I'm trying to get everything on the left-hand side so that I can simplify. So I keep going by subtracting cosine x from both sides. And I end up with the following expression: sine of x times cosine of x minus cosine x equals 0. So from here, I can factor out a cosine of x, and I'll get sine of x minus 1 equals 0. And the zero product property tells me that if I have two numbers or two things that multiply to give me 0, they both have to equal 0, one or both. So we get cosine of x equals 0 and sine of x minus 1 equals 0. Okay, and so someplace where you might have seen this before, for example, if you were factoring in college algebra and you had something like x minus 3 times x plus 4 equals 0, well then you would set both of these equal to 0 to solve for x. And so that's the property that we're using here to solve this equation. So if we keep going, I'm going to cosine of x is equal to 0, sine of x minus 1 is equal to 0, so that means sine of x is equal to 1. So to find the exact solutions between 0 and 360 degrees to this equation, I need to figure out whether cosine of x is equal to 0 and the sine of x is equal to 0. So the cosine of x is equal to 0 when? It's equal to 0 at pi over 2, or 90 degrees, and at 270 degrees, so 3 pi over 2. And when is the sine of x equal to 1? The sine of x is equal to 1 at 90 degrees. And also, and that's it. So the final solution is just going to be, so we get that x is going to be equal to 90 degrees and 270 degrees. So quickly, just to check to make sure that our answers are correct, let's do that over here. So first we're going to plug in 90. So we want to confirm that cosine of 90 is equal to cotangent of 90. And so we're going to get cosine of 90 is just going to be 0. And cotangent of 90 is cosine of 90 over sine of 90. And so that's going to give us 0 equals 0 over 1. So 0 equals 0. So it does work. Okay, so let's try for the other solution. We have cosine of 270 degrees. Does that equal the cotangent of 270 degrees. So the cotangent of 270 degrees is cos of 270 over sine of 270. And so we want to check to see if this is a true statement. So cosine of 270, that's cosine of 3 pi over 2, which is just 0. And we've got cosine of 270 again is 0, and then the sine of 270 is negative 1. So we get 0 equals 0, so our answer holds up, or checks out rather. Okay, so we have just done several examples for solving trig equations using a little bit of algebra. In class on Monday, we will do this with more extensive techniques, namely factoring and using the identities from Chapter 4.